Number 17, we have 1.25 times 10 to the negative 15, all being raised to the negative 5. So let's see what we have to do. So I'm going to have to raise each of these to the negative 5 power. So we have 1.25 to the negative 5 power and 10 to the negative 15 to the negative 5 power. So 1.25 to the negative 5 power is going to give me 0.32768. Negative 15 times negative 5 is 75. Okay, so now I'm going to have to put this into scientific notation. So I need to have this number be between 1 and 10, so I can move the decimal place to the right one. So I'll have 3.2768 times. When I go to the right, I got to subtract 1, so I have 10 to the 74. So that would be my answer, so let's put that in. So typing it in, I have 3.2768 times 10 to the 74 power. And that's number 17. Number 18, the expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.8 times 10 to the third kilograms traveling at a speed of about 3.2 times 10 to the third meters per second? We're going to need to substitute in for our formula. M is going to be the mass, that is 1.8 times 10 to the third. V is going to be our speed, and that is 3.2 times 10 to the third power. So it should look like this. It's the 3.2 times 10 to the third that's being squared because we have v squared in the formula. So we rewrite what we have here, but then we're going to square out the last one. So we have 3.2 being squared and then 10 to the third being squared. So 3.2 squared is 10.24. 10 to the third squared, you multiply 3 and 2 because it's an exponent being raised to a power, and you get 10 to the sixth. Now we got to multiply all of these together. So multiply all of the numbers in front, not the tens with the exponents together. So 1/2 times 1.8 times 10.24, that'll give us 9.216. Multiplying the tens together, 10 to the third times 10 to the sixth, you add the exponents, 3 plus 6 is 9, so I'll have 10 to the 9. Luckily, my answer is already in scientific notation, so all I have to do is type it in. So I'm going to type in 9.216 times 10 to the 9th power. And that's number 18. Number 19. You are being asked to find the exponent such that if you raise c to the 5 to it, you'll have c to the 10. So let's take a closer look. We know that when we raise the exponent to a power, we have to multiply the exponents together. So 5 times the number is 10. So 5 times 2 is 10. So your answer is going to be 2. So type that in. And that is your answer for number 19. Number 20, we are doing a similar thing in that we're looking for the missing exponent. So let's take a closer look at it. So what we're looking for is the exponent on x. Now notice how over here we have no more x. And the way to get rid of that would be if we had something that would make x go away. We know a variable to the 0 power is going to give me 1. So in order for me to have this go away and leave me with no more x's, I need to multiply this 6 by something that will give me 0. 6 times 0 is 0, so my answer will be 0. Typing that in, my answer will be 0 for 20. Okay, let's take a look at 21. So we have an expression that needs to be simplified, so let's take a closer look at it. So whenever I'm given something like this, I always want to take care of the exponent on the outside here. So I'm going to have c to the 7/8 being raised to the 4 power. When I raise this to the 4 power, I multiply these. So 7/8 times 4 gives me 28/8, because 7 times 4 is 28. Now notice how both of these have the same bases, so that means I add the exponents. We're lucky in this case in that both of these have the same denominator, so we just add up the numerators. 28 plus 3 is 31. So my answer is going to be c to the 31/8. Always check to see if it can be simplified. 31/8 cannot be simplified, so that would be our answer. So leave it there. So we'll type it in on MathXL. So c to the 31/8. That's number 21. All right, number 22. We are simplifying the following expression. So let's take a closer look and see what we would need to do. So I have each of these being raised to a power. So let's take each one of these and raise it to the power. So 7 to the 8 power being raised to the second power, I multiply the 8 times 2 and I get 16. So 7 to the 16 power. I then take this one and raise it to the second power. So negative 7 times 2 would be negative 14. So now that I raised the powers, these are just being multiplied to each other. So that means I add the exponents. So 16 plus negative 14 is just going to be 2. So we have 7 squared. So let's put that in on MathXL. Now it says to type in exponential notation, so just leave it as 7 squared. And that would be my answer. That is number 22.